Hello. Today we are going to finish talking about El Nino, but in order to effectively talk about El Nino, I suppose it's important for us to understand what a normal weather pattern is, an ocean pattern, in order to really understand the difference between when an El Nino event happens and when it doesn't happen. So with this drawing, we're going to go ahead and draw a distorted. Ooh, let's change our colors. We're going to draw a distorted Australia. It's going to have a very long shape because we want to show deep ocean currents that have an effect on certain things. So it's going to look something like this. And then there's this long area down here. And this is our Australia. And then over here it's important to note there's Tahiti. And I'll explain why it's important in a minute. And over here we have, of course, New Guinea. And then we have this very important line of latitude called the equator. And of course over here we have North America and South America. So typically what we would see cool ocean currents driven by trade winds flowing in this direction. And they shift towards the equator due to the Coriolis effect at the intertropical convergence zone. But then, as these cool waters go towards the equator, they warm. And they continue on this pattern along the equator. They move north, and actually they start to cool. And then we have this continual convection cycle continue. And they continue. Probably should just. So again, these trade winds drag warm water westward. So it's a common theme that temperature differences. Temperature differences affect atmospheric pressure, and then atmospheric pressure affects winds. So somewhere around the world, when we get to El Nino, there is a temperature difference that's occurring which affects atmosphere differences. And that's going to drive the winds to move in a different direction. Okay, so one of the reasons why we did a distorted look of Australia is because deep in these ocean currents, actually let's go to straight line. Text. We have thermocline. A thermocline is a layer of water in an ocean or certain lakes where the temperature gradient is greater than that of the warmer layer above and the colder layer below. And we're going to move this guy down here. So over here we have this cool water. Oh, I don't remember doing that. Which flows up, causing or these cold waters well up to take place of warm water. Well, this would just make that clean. So cold water wells up to take place of warm water moving westward. And this is typically what we would see in a normal pattern in the ocean. Of course, over here in Australia, the pressure is low. Over here. And of course, let's go ahead and identify Darwin, Australia, which is right here. And we'll go ahead and make it easily identifiable. Darwin. And so there's Darwin in Australia. The pressure is low, and the pressure by Tahiti, well, actually the pressure over here is going to be high. This is the area of cool water. However, when we start to experience El Nino events, there's a different pattern that emerges that looks something like this. Again, we'll need Australia. We'll do my distorted version. Oh, here, let's do. This separates the two. So if you were writing in your journals, in your notepads, because if you can't write it or say it, you don't know it. So if you're doing this as a writing exercise to help your long-term memory, here's Darwin again. This is going to be our El-Nino side. Of course, here's our New Guinea. And then over here we have our North America and South America. Of course, over here we have our Tahiti. And the differences we start to notice is that there is a reversal somewhere. So somewhere there's a temperature difference that has an effect on the atmosphere. And atmospheric pressure drives winds. And these things reverse course. And then now you have warm water flowing this way, where cool water used to be flowing from west to east. Now warm water is flowing east to west, so there's a reversal that happens. And then these waters start to cool. The further north it travels past the equator. So trade winds reverse direction and drag warm western water back to the eastern edge of ocean. So there's a certain pattern that scientists notice that in Darwin, Australia, the atmospheric pressure is higher, and in Tahiti it is low. And then they anticipate, when they see this pattern, that El Nino is going to occur. So, in essence, the El Nino event is a reversal of the ocean pattern due to some kind of temperature change somewhere around the world, which causes an atmospheric difference, and atmospheric differences drive winds, and prevailing winds have a close relationship with ocean patterns. So where the winds go, they also have effect of moving the top layer of the ocean. And this is what we see. So El Nino, in essence, is the warming of the ocean, at least towards the South America and North America, and that has a long-term, or that can have a devastating effect as far as floods and drought in a number of places around the world, and extremely dangerous tornadoes that occur in the U.S. Well, we have tornadoes anyways, but they're going to have a greater effect as a result of these El Nino events. So, all right. Well, that's El Nino in a nutshell, and I hope this helps you guys out. And I'll see you in class. Adios.